All right, now, one of the sections we talked about were inverses. And you had in 2.7, you had like 3 worksheets to do with inverses. Those are actually due tomorrow, by the way. And so remember, when we talked about inverses, in order for 2 functions to be inverses of each other, they first of all had to be what kind of functions? One-to-one. They had to be one-to-one functions. So if a function's one-to-one, then it has an inverse. And then when we graphed it, when we graphed those functions that were inverse of each other, they were symmetrical about what line? Y equals x. All right, so you graph the line y equals x, that dotted line, and then you notice that they were symmetrical about that line. So you're going to learn within the next 2 days that exponentials and logarithms are inverse functions. Exponentials and logarithms are inverse functions. So they're inverses of each other. Okay? All right, so remember what an exponential looked like. So an exponential function the definition we said was this: f of x equal b to the x. Remember that? So you had a bunch of graphs, a bunch of worksheets where you had to graph these things. 2 to the x, 3 to the x minus 4. You had all that to be turned in. But that was the definition of an exponential function. You're also told that b had to be what kind of number? Positive, and it could not be what positive number? 1. It cannot be 1. So you remember all that stuff. And also remember that I can also rewrite this. Instead of saying f of x equal b to the x, I could have said y equals b to the x. Okay? All right, so we did a lot of stuff with this idea of exponential functions. We spent a lot of days on it. We're not going to spend a lot of days on logarithms. First of all, we don't have that many left. You can see the light at the end of the tunnel. All right. So let's talk about logarithms now. So our new concept is about logarithms. Okay, so one of the things you're going to learn Tuesday is that when you graph this, when you graph a log function and an exponential, you're going to see that when we graph them, they're going to be symmetrical about that line y equal x, meaning that they would be inverses of each other. Okay? So logarithms and exponentials are inverses of each other. That's going to be Tuesday, though. What I want you to notice right now is this. So let's talk about the definition of a logarithm. So we know what an exponential function looks like. It's f of x equal b to the x. A logarithm looks like this. F of x equal log of x base b. Notice what the base looks like. What's the base of that log function right there? B. It's written as that subscript, right? But here, remember how I read it? I read it as the log of x base what? B. When I did the exponential, I said f of x equals b to the x. Here, I say f of x equal what? Log of x base b. Okay? All right, so that's what a logarithm looks like. All right, now a couple other things. On your calculator, and I just want you to do this in your calculator. We're going to talk about this probably later on today, maybe Tuesday, I'm not sure. But on your calculator, I just want you to notice something. Just press the LOG button. See, it's right here. Take the LOG button and punch in the number 2.8. Close the parentheses, press equal. All right. Now you have no idea what that means, but the log of 2.8 is approximately equal to what? 0.447. Okay. All right. Now I want you to do this. Take the log and type in 0, what do you notice? You get a domain error. You get a domain error. Now, when we did exponentials, what was the domain of these exponentials when we graphed them? What was the domain? Negative infinity. Very good. So it's any real number. Logarithms, though, that's not true anymore. The domain is not all real numbers, because I just saw that I cannot use 0, right? I can't take the log of 0. That's undefined. All right? And now I know I can take the log of a positive number, but I can't take the log of 0. Now you're going to see why as we go through this. But what about a negative number? Can I take the log of a negative number? Type in the log of -4. You get an error as well, right? You get a domain error. So you're going to learn either later on today or Tuesday how to find the domain of a log function. It's pretty easy how to find the domain. But what's the domain of an exponential? All real numbers, right? Negative infinity to infinity. Okay. All right. Now listen carefully to this part. Watch how I'm writing this. This, and I'm also going to rewrite f of x as y. So y equals log of x base b. Now, when you write these log equations or these log functions, you better make sure that the base looks like a subscript. Don't all of a sudden do something like this. Is that how the base is written? No, it looks like you're saying the log of b times x. So make sure that you're writing the base as a subscript. So don't write it like this. Take the time and say log of x and then say base what? B as a subscript. All right, now listen carefully to what I'm about to write. So this log equation right here is equivalent to, all right, now listen carefully. I can, remember we said that exponentials and logarithms are inverses of each other. They're one-to-one. So I can write this log equation in exponential form. I can make it look like this. All right, now here's how I'm going to do it. Listen carefully. First of all, find your base. What's my base? B. When you talk about exponential form, you have an exponent, right? Okay? So you're going to say this. You're going to say, well, what is my exponent then? All right, do this. The base raised to this power on the other side. So you're going to say b to the what? Y equals x. B to the y equals x. So y equal log of x base b is equivalent to what exponential form? B to the y equals x. Okay? So knowing this right here, you're going to now be able to change a log equation to an exponential equation, and then vice versa. Change an exponential equation to a log equation. So you can go backwards on these. Go from log equation to exponential, from exponential to logarithm. Okay? All right, so let's look at some examples with this first part. All right, so the direction is going to say something like change a log equation to exponential. Change from log equation to exponential. All right? Okay, the first one. 3 equals log of 216 base 6. That's 6. Notice how I read it. That's a 6, by the way. It looks like a B. It's a 6. 3 equals log of 216 base what? 6. Notice I use the word base. What form is this in? Log what? Equation. There's an equal sign. It's a log equation. I want to change this log equation to what kind of equation? Exponential. To change an exponential, you first of all have to find your base. What's my base? 6. So you're going to say 6. So the answer? Raised to a power. Which power am I going to use? 3. Good. Equal 216. And by the way, we're going to call this 216 the argument. A-R-G-U-M-E-N-T. So this right here, we're going to call the argument. All right. And that's all you have to do. Now listen carefully. On your calculator, what is 6 to the third power? What's 6 to the third power in your calculator? 216. So the log of 216 base 6 is going to equal what number? 3. So notice, I want you to notice something. Look carefully. You see this 3 right here? That's this exponent, right? You're going to also learn as we go through this that logarithms are nothing more than exponents. They're exponents. So this log expression here is the exponent of this exponential. All right, number 2. 5 equals the log of m base 3. 5 equals the log of m base 3. What form is this in? Log equation. I want to change it to an exponential equation. To change the exponential equation was the first thing I got to find. The base. What's the base? 3. What am I raising it to? And what does that equal? The argument m. You're done. That's all you do. Let's do one more with this. Number 3. Suppose I had log of 4096 base 8 equal y. What equation is this? I want to change it to an exponential. I got to locate the base. What's the base? 8. Raised to what power? The y, and that's going to equal? 4096. All right. So that's going from log equation to what kind of equation? Exponential. All right. Now let's go backwards. So let's change from an exponential equation to log equation. So I'm going to go backwards this time. And all you need to be able to know is this, right here. That's all you need to know. Y equals the log of x base b is equivalent to b to the y equal x. That's all you have to know. All right, number 1. 4 to the fifth power equals 1024. 4 to the fifth power equals 1024. So we're going to change this to a log equation. All right, now listen carefully. I know that when I change to the log equation, I have to use the letters log, right? So the answer, I'm going to have to use the letters log. Now when I write log, I've got to have a base and an argument with it. I know my base right away. What's my base? 4. And I know, now remember, the best thing to do is this. So once you find, and you know there's going to be an equal sign here, once you find your base, you say this. 4, remember how we do this, 8 to my power, 8 to my power equals the what? Argument. 4 to my power, and what's my power here? 5 equals the argument. What's the argument?
24.
And you're done. That's all you do. So 4 to the 5th power equals 1,024 is equivalent to that log equation. And always make sure you check yourself. 4 to the 5th equals 1,024, and that's what this is. Number 2, suppose you had z, that's a z, to the 4th equals 5,010. 510. 510. So you're going to have equal log, right? What's the base of that logarithm?
2.
That's a z.
Oh, that is a Z.
So write as a subscript, though. Make it look as a subscript. So then you're going to say this. Z to my power, so what's my power? 4 equals the argument. What's the argument? So there we go. That's it. Number 3, 7 to the c power equals 41. So you're going to have equal log. What's the base?
7.
What's on the left side? 7 to the c. And the argument is 41. All right, now, let's see if you remember this. Okay, so we may have to do some discussion from both 98 and 99 with this one. Square root of 25 equals 5. Y'all agree that's a true statement, right?
Mm-hmm.
Okay. What is the difference between the way number 4 looks and numbers 1, 2, and 3? Numbers 1, 2, and 3, you actually saw an exponent. Number 5 and number 4, you don't see that. But what do you remember about the square root of 25? How can you write that? Say it.
Square.
No, I agree. The index is 2. Square root. Index is 2. How can you write the square root of 25? What's another way you can write the square root of 25? Don't say 5. We know the square root of 25 is 5, but that's not what I'm asking.
Oh, square root of 25 squared.
Okay.
Obviously, we don't remember.
Yeah. All right, so let's take 2 minutes and review Math 98 and Math 99. Huh? Say it again? No. All right. If I have 8 to the 1/3 power, without using a calculator, where you have those rational exponents, those fractions and exponents, you can always write that expression as a radical. You can always write these rational expressions as radicals. You have to remember this. You have to remember that the denominator is your index. And the numerator is your exponent. So in other words, I can write this as the cube root of 8 to the 1st power. So if I had 16 to the 1/2, then I can write that as what? Radical.
2, so like square.
Square root of 16 to the 1st power. If I have 8 to the 2/3, I can write it as radical. Remember, what's my index? 3. So hence cube root. So it'll be the cube root of 8 all raised to what power? 2nd. That's what that is. So when I go back over here and I look at the square root of 25, then now you know that the square root of 25 is 25 to what power? Tell me. 1/2. 1/2. Because my index is 2. This exponent right here is what? 1. So this becomes 25 to the 1/2 equals 5. So when you have radicals, and you will, you have to rewrite the radicals as rational exponents. All right, so now tell me what the answer is. 1/2 equals, so you're going to say equals log, what's the base? 25. 25 to what power? And what's the argument? 5. All right, that's all you do. Now notice that not one of you, it's been a while. I mean, a lot of fun occurred since last semester to now. All right, let's look at number 5. The cube root of 8 equals 2. That's a true statement, right? Cube root of 8 equals 2? Okay. But I want you to rewrite this in as a logarithm. First of all, you got to rewrite this where you can see an exponent. So 8 to what power? 1/3. 8 to 1/3. Kind of makes sense because the denominator is your index, hence cube root. And that 1 is your exponent. There's nothing there, so this should be a 1, right? So 8 to the 1/3 equal 2. So now the answer is going to be log. What base? So 8 equals, so 8 to the what?
1/3.
And what's my argument? 2. All right. Yes.
On number 4, how do you do 1/5 equals? I know we went over the other stuff,
What-
lesson.
What's your question?
How did you get 1/5 equals? I know you got log 20,
That's not supposed to be 1/5. That's supposed to be what? 1/2.
but how did you get 1/5? Oh, okay, different.
Your exponent is 1/2.
Yeah, I see.
25 to
I was
1/2.
trying to figure out how did you get 1/2, that's all. I mean 1/5.
Okay. Well, it wasn't supposed to be 1/5. It's supposed to be 1/2.
All right, thanks, and I
Uh-huh.
was just half.
All right, so let's look at this. Evaluate the following logarithms. And I put 1/5 because someone said 1/5. I really wasn't looking at this. Evaluate the following logarithms. So I'm blaming it on someone. I always blame someone else.
I get a smile face. I caught that.
Evaluate the following logarithms. Someone give her a smiley face.
I agree.
Girl, you get a 9, at least a 90 on that test. You get a smiley face. Evaluate the following logarithms without using a calculator. What? So evaluate the following logarithms without using a calculator. So your good friend is going to be put on the side for right now. Number 1, log of 81 base 9 equals blank. Log of 81 base 9 equals blank. What is it equal to? Huh? 9? First?
Second power.
Second? All right, here's what you do. We just saw that I can write a log equation as a what? Exponential. So why are you making this difficult? What goes in that blank, you think?
2.
2. 2 goes in that blank.
But how do you get 2 from that?
His question is, how do you get that from that?
I mean, we know it because it's an easy thing, but how do you get there?
log of 81 base 9 equals box, right? I can change this to an exponential. 9 to the box equal 81. What is box? 2, because 9 squared equals 81.
Exponential.
You got to use what you just learned.
Exponential is X.
Number 2. Log of 16 base 2 equals blank. Four. Makes sense, right? Because look. Think changing this to an exponential. 2 to what power is 16? 2 to what power is 16? 4. Answer is 4. Notice I said this. 2 to what power is 16? That's what I'm asking. So 4 goes in that box. Number 3. Log of 1/5 base 5 equal blank. 5 to the first power is 5. What goes in that blank? So remember, let's first of all rewrite it. So you're going to say 5 to the box equals 1/5. Now, obviously, you know that's not 1, right? Because 5 to the first power is not 1/5.
Right.
5 to what power is 1/5? Negative 1. We talked about the negative exponents in here, guys. Remember that? We were graphing these exponentials. 5 to the negative 1. Because let's think about that. Now remember we talked about this when we did those exponential graphs. If I want to make this exponent a positive 1, what do I do to the base? Take the reciprocal. So 5 to the negative 1 is 1/5. You've got to stop learning things in isolation. Everything you learn, they build upon each other. You use it. So the answer is negative 1. Number 4. Log of 1/7 base 7. Negative 1. Negative 1. Because 7 to what exponent is 1/7? Well, 7 negative 1 is 1/7. Number 5. Log of 1/25 base 5 equals blank. Huh? Negative 2. Very good. Negative 2.
He really gets the smiley face.
He's trying to redeem himself from yesterday afternoon. Huh? All right. So you're going to say this. You're going to say 5 to the box equals 1/25. So what's that exponent? Obviously it's not 5 squared, because 5 squared is 25. But I'm almost there, because I know 5 squared is 25, right? But I don't want 25. What do I want? 1/25. So instead of saying 5 squared, you can say 5 to the negative second. Because remember when we talked about negative exponents. When we talked about negative exponents, if I want to make this exponent a positive 2, I've got to do what to this base? Take the reciprocal. So that's 1/5 squared. That is this. But 1/5 times 1/5 is what? 1/25. And so that's what this is right here. So the answer is negative 2. Number 6. What is the log of 1 over 81 base 9? Negative 2. Because 9 raised to what power is 1 over 81? Not 81, 1 over 81. But use the 81. 9 squared is 81. But I know it's not 81 I want, it's 1 over 81. So it has to be 9 to what power instead? Negative 2. Number 7. Log of 1 over 27 base 3 equal blank. Not 9. Negative 3. Negative 3. The answer is negative 3 because think, 3 to what power is 1 over 27? So think 27. 3 to what power is 27? The third. But I don't want 27, I want 1 over 27, so it has to be 3 to what power? Negative 3. All right, now let's look at number 8. Log of 6 base 36 equals blank. Very good. He remembers what we just talked about. 1/2 is the answer. Because let's think about this. Think about it. This is what I would do. 36 to what power is 6? Well, what can I do to that 36 to get 6? In general, what can I do? No, divide by 6. That is true. But if this was 81 to the blank equals 9, you're going to say divide by 9. No, that's what you're going to do. Square root is what I wanted you to say. Square root. The square root of 36 is 6, right? So now you know what that box is. What's that box? 1/2. Remember, we just talked about square root in the previous problem. Square root you can write as 36 to what exponent? 36 to the 1/2. So that's 1/2 right here. 36 to 1/2 is 6 because the square root, remember 36 to 1/2 means square root of 36. The square root of 36 is 6. Number 9, log of 8 base 8. Now all of you better get that one. 1. 8 to the first power is itself. Number 10, all of you better get this one.
0.
She's right. She's right, because look, log of 1 base 9 means 9 to what power is 1? 9 to what power is 1? 0. Remember, any number raised to 0 power, we had something like that in here. Any number raised to 0 power is what? 1. Log of 9 base 81. Log of 9 base 81. Huh? 1/2. The square root of 81. That is 81 to the 1/2 power because that means the square root of 81, which is what? 9. All right, number 12. Log of 3 base 27 equals what? 1/3. So 27 raised to what power is 3? So I know that the cube root of 27 is what? 3. Cube root. Makes you put the index. Cube root. I left the index off. That meant square root, right? All right, so I need the index 3. So cube root of 27 is 3. But you now know how to write a radical using exponents. What's this the same as? 27 to what power? 1/3. And that's what goes here, 1/3. All right, now listen to this. Listen to this. $13. Okay, log of 3 to the 4th power, log of 3 to the 4th power. So right away you know that the argument is what? What am I taking the log of? 3 to the 4th. Okay. Base 3 equals blank. Log of 3 to the 4th power, base 3 equals blank. What goes in that blank, do you think? Huh? Okay. You're not losing. You're not using what we've been doing in the previous 12 problems. When we did the previous 12 problems, we said the base is 3. So we say 3 to the blank equals the argument. What's the argument? Come on, guys. Tell me what the answer is.
We 81. Second part.
Oh, my Lord. People, y'all learned in one of the worksheets that when the bases are the same, what can you say to the exponents? They're the same. What is it about the bases? So what goes in that box? 4. Y'all are not connecting some things. So 4 is the answer. So if I had this, log of 7 to the, let's make it the x power, okay? Base 7. What does that equal to in that blank? X. X. Because, what?
What is that in 0? Or is it like, yeah, 7, 7, and 0, would it ever be anything like that?
7, 7, and 0.
Saying if instead of x, if that was the 0 power.
Then you put 0 in the blank.
Okay, so
We're saying 7 to the box equals the argument. What's the argument? Not x, David. 7 to the x. You learned in the previous section that when your bases are equal to each other, what else must be true? The exponents have to equal to each other. So box has to equal what? X. The answer is x. All right, now this one's going to cause you some issues.
You mean we haven't already had it?
All right, listen to this one.
He said you've been having issues since June 3rd.
Who said that?
He said you've been having issues since June 3rd.
Did it just start June 3rd? Did it start June 3rd? All right, 7 log of 9 base 7. I know, right? 7 log of 9 base 7. All right, that one is a little bit more confusing. That really gets, in terms of understanding, you see these, number 13 and 14, it's understandable why those are the answers. It makes sense now because I said 3 to what power is 3 to the 4th, and we know that when the bases are the same, what has to be true? Exponents have to be equal to each other. So that makes sense. Here, It really doesn't make sense because first of all, it's not written as a log, it's written as an exponent. The log's in the exponent. All right, so I want to talk about something real quick. We know this. We know that let me make sure I'm using the right notation. Okay. So when we talked about the exponential function, we said f of x equals b to the x, right? Do you agree? Okay. And then I rewrote this as y equals b to the x, correct? All right. Now I'm going to interchange. Remember when we were finding the inverse? I'm going to interchange this now. I'm going to say x equal what? B to the y. And now I'm going to, now remember earlier we went from an exponential to a what? Log. So let's write this as a log. So this right here, we write as a log. So this is the log. What's the base? B. Okay, so b to what power? What goes here? Y. And what's the argument? X. All right, now, listen carefully. You see this y right here? See this y? Okay, that's this y right here, right? So I'm going to put this right here in this exponent. So I get x equal b raised to the y, and what's this y right here? Log of x base b. All right, now, you see this argument right here? Where's it also located? On the other side. So what this is saying is that when the bases are the same, when the base of the logarithm and when the base of the expression are the same, it's just a what? It's just the argument. So in other words, if the base here is the same as this base here, then what's the answer? 9. It's just 9. The base are the same. So 16, what is 8 log of 6 base 8? What are you going to say? 6. Because of this right here, because of the fact that remember earlier we said that a logarithm is nothing more than an exponent? That's where that comes from. Okay? All right, now let's do a couple of problems on the worksheet. We'll do a little bit of that.